Hey guys, welcome back to another GCSE maths video. This time we're talking about vectors, specifically how we can prove that two vectors are parallel using exam questions. But before we get started, I just wanted to let you know that the majority of you who watch these videos aren't subscribed. So if you've ever found any of these videos useful to you whatsoever, if you could please just click the subscribe button, it really helps me out. Without further ado, let's jump straight into this question. So before we get started, we have to prove that two vectors are parallel. But what does that mean? Well, when you have a vector, for example, the vector 1, 1, or if you wanted, that could also be, a plus b. All that means is it's going 1 unit to the right and 1 unit up. So it's a straight line just going like that between 2 points. If I double it, for example, and make it 2, 2, which again could be also written as 2a plus 2b, all that would do is it would stretch out, thanks Microsoft, I appreciate it, stretch the line to make it twice as long. So essentially, when you have vectors, if they are scale multiples of each other, it means that they are parallel. Now, a lot of people have a bit of trouble understanding what I mean by scale multiples. Basically, if you can factorize out an integer from here, so if I look at 2a plus 2b, imagine it's just normal algebra, you could factorize that to give you 2a plus b, right? If you notice, that is this vector multiplied by 2. That means that these two vectors, if I want to call this vector 1 and vector 2, are parallel to each other. And this actually works for fractions as well. So again, if I have that a plus b, and I have something like a half a plus a half b, again, we can factorize out 1/2. So the aim of this game, so to speak, is to work out the vector PQ, work out the vector FE, and try and factorize it so we can write one vector in terms of another. So again, for example, if it was a plus b and then a half a plus half b, my goal is to write it in the form where I will have a plus b inside a bracket. That's the end goal for this. So, starting off, with vectors, I always give a few kind of pieces of advice. The first thing I'll do is, if they haven't written on the diagram what vectors they've given you, I would recommend doing that first. So first things first is FD is A, so F to D. Remember, it goes left to right like you're reading a book. We're going from F to D. So this vector here is A, and then F to E is B. So the vector directly along here is B. Perfect. They usually always give you one or two of these, normally two to be honest. And let's read some other information. So we've used both of this information. It says P is the midpoint of FD. So what that means is each part of this, so from F to P is a half A, and from P to D is a half A as well, because it's halfway between it, right? So if the full length was, let's say, 10 centimeters, each part would be 5 centimeters. Same thing here. And then we also have Q is the midpoint of DE, so again we can say that's a half and a half, but I don't know what the vector DE is, so I can't write anything else. And now it's saying use a vector method, so that might sound a bit fancy, basically just using the algebra I showed you just now. Prove that PQ and FE are parallel to each other. So what we need to do first, and this will always gain you some marks, so this is a 4-mark question, you'll always get around 2, maybe 3 marks if you're lucky, to work out PQ and FE. Normally it's 3 marks. So, P to Q. Well, if I start at point P, I'm trying to get to Q. Now how can I go there? Well, I can't go straight to the right. Instead, I have to go along these lines, okay? Imagine that you're kind of trying to walk across these lines like roads. You have to walk across the road. You can't just like create a brand new one in the middle. So I have to go from P to D and then from D to Q. I would write that out first because I personally think that it helps me a lot. So we have P to D and then we have D to Q. And then what I'm going to do is I'm going to ask myself, well, do I know what P to D is? Well, P to D is just a half A. We've already got that. Perfect. And do we know D to Q? Well, we don't. But I do know that D to Q is half of D to E. So I'm going to write half DE. Remember that the point Q was halfway between D and Q. It's the midpoint. Okay. Does that help me? A little bit. Because I couldn't work out what DQ is, so now I've changed it in terms of DE. I've got half DE. Can I work out D to E? Well, again, if we get rid of those 2 points, if I start from the point D and I end up at the point E, I could go straight down here, but I actually don't know there's no vector that goes from D to E yet, right? I can't actually just go straight from D to E. But I do have a vector that goes from D to F and then F to E. So that's the way I'm actually going to go. I'm not going to go straight down here because I can't, there's no vector. I'm going to go down and to the left and then to the right. The second piece of information I like to give students with vectors is you have to go along vectors that you know or you can work out. I don't know the vector D to E. So instead I have to go along the ones they've given me, which is D to F, F to E. So let's do that. So we now have a half A, because that's from the previous part, plus a half, and then D to E. Well, I need to go from D to F. Here's the third thing. If you notice, my arrow for A is going up and to the right. In this case, I'm going down and to the left. So instead of A, it's actually going to be negative A. Remember from science, potentially, vectors have direction as well as size. So it's not just going, I'm not just going A, I'm going A in a certain direction up and to the right. So if I'm going in the opposite direction, so again, I'm going downwards, I need to make it negative instead. And then lastly, F to E, well again, I'm going in the same direction as the vector, right? I'm going from F to E, so I'm going this way. So it's just going to be plus B. And then from here, we can just expand this in order to work it out. I'll do this in a few steps. So a half A minus a half A plus a half B. So yep, half A, and then if we expand this, we have half times minus A, so minus half A, half times B is half B. So in short, P to Q is just a half B. Now for the vector FE, we actually already know it because it gave it to us in the original, in the actual question itself. FE is B. So all we need to do is say that that equals B. That right there gives you 3 marks. So you get 1 mark for writing this general expression over here. Another mark for working out what DQ is. So in this case, we worked out DQ over here. The final mark for simplifying it. The 4th mark is for actually explicitly showing that PQ and FE are parallel. And this is where some students lose some marks. Well, a mark in this case, because they don't explicitly show it. I'm going to show you how I would do it. Now, factorizing a half B might seem a bit strange, but instead I can say that FE is equal to B, so I can just replace B with FE. So that means PQ is equal to a half FE. And again, remember, if you're factorizing it, you'd write it like I did originally. So if it was a half B plus half A or whatever, you'd factorize it, then do this. And then I'd say, therefore, PQ and FE are parallel. And that way, you can be super, super, super specific and explicit about why those two vectors are parallel. In the most recent exam series, so the 2024 exam series, when students got results, they showed me some of their papers, and a lot of them would lose the final mark in questions, not necessarily vector questions, but in questions because they weren't explicit. You have to really show this. And I know that when you're revising, you might want to skip this because it gets a bit tedious. Therefore this, therefore this, therefore this. But you need to remember when you're in a mock exam or an actual exam, you need to be very specific. Because if I'm an examiner, I'll look at this and go, okay, oh, I see this, where their reasoning's good. Then I'll check their working out. If I don't see this, I might be a bit more skeptical. But hopefully that kind of helps you with dealing with the vector questions, especially when they say show that they're parallel. Remember that there are other versions of this, so they might say, given that they're parallel, find one of the vectors or find K or something along those lines. I will have a video coming on that shortly, but again, if you found this useful, please consider subscribing just to help me out a bit more, and I'll see you in the next one.